Most of us grow up hearing that magnetic fields are the weaker version of electric fields. But what if that idea is more of a measurement trick than a scientific truth? What if magnetism isn't weaker at all, but simply misunderstood? Stick with me, because this can completely reshape the way you think about electricity and magnetism. Hey everyone, and welcome to Mind Blown Science. This is where we explore big ideas in physics, math, and the nature of the universe. If you're curious about how reality works, from the smallest particles to the largest structures in space, you're in the right place. Make sure to subscribe so you don't miss our upcoming deep dives.
A question has been making the rounds lately. Are magnetic fields really weaker than electric fields? It's something people repeat a lot, and it sounds simple until you look closer. The truth is far more interesting than a yes or no statement.
When light, or any electromagnetic wave, travels through empty space, the electric and magnetic fields move together, perfectly linked. Their magnitudes follow a straightforward rule: E equals C times B. This means the electric field has a numerical value about 300 million times larger than the magnetic field, since it's multiplied by the speed of light. But here's the catch. That difference comes from units, not from true physical strength. The energy carried by a wave is split evenly. Half in the electric field, half in the magnetic field. Neither one is the boss.
One of the most elegant truths in physics is that magnetism isn't a standalone phenomenon. It's what an electric field looks like when charges move, or when you move relative to them. Change your speed and what appears electric to one observer becomes partly magnetic to another. They're two aspects of the same.
In daily experience, electric fields can push or pull stationary charges instantly. Magnetic fields only exert force when charges are moving. Most things around us don't have charges zipping around fast enough for magnetic forces to stand out, so magnets seem gentle compared to a static shock. But step into a particle accelerator, a fusion experiment, or Earth's magnetosphere, and magnetic forces become anything but weak.
Saying magnetic fields are weaker isn't accurate as a universal rule. A better statement is, electric and magnetic fields have different units, different roles, and different effects, but neither one is inherently weaker. Their strength depends entirely on the physical situation. Both are essential partners in one unified field that shapes how energy moves through the universe.
If you enjoyed this explanation, stick around and explore more with us here on Mind Blown Science, where curiosity always has room to grow.